The following are the problem-solving steps in physics. 1. Read the given problem carefully. Reading the problem itself is an art. While reading the problem only, we should be in a position to grasp the content and also identify known and unknown variables. 2. Representing the given situation in the form of a diagram. Draw relevant diagrams wherever necessary. 3. Choosing the right equation or formula. This is a crucial task, as far as physics problem-solving abilities are concerned. Because there are innumerable formulae which are to be identified at the time of solving problem. Depending on the situation, we have to select the suitable formula. 4. We are also required to identify dependent and independent variables. Sometimes logical method also plays a vital role at the time of solving problems. 5. Consider all the possible approaches leading to solve the problem accurately. 6. After selecting the suitable formula, substitute all the known or given values carefully in the appropriate formula. Perform necessary calculations with the help of algebraic identities or trigonometric identities. At the same time, identify whether the given quantities are vectors or scalars. 7. We also need to ensure that all the given units are SI units. If necessary, convert the given units into SI. 8. Generally, physics problems are very lengthy in nature. Hence, divide the given problem to smaller parts and comprehend them in order to arrive at the reasonable solution. 9. We generally try to by heart all required formulae in physics specially. Though it helps you to solve the problem to a certain extent, we should also have some idea about the derivation. Because there are so many conjuncts involved with little variation, it becomes difficult to remember all the formula without understanding them. 10. Practice regularly to get the accuracy and precision. 11. In this video, I will tell you how to identify the required formula and apply them at the time of solving. Please do watch, share and subscribe Srinivasu SR Chaganti to get the continuous updates. Welcome back to my YouTube channel, Srinivasu SR Chaganti.
Particle enters an electric field E and magnetic field B with a velocity V, then the force experienced by the charged particle in the presence of electric and magnetic field is given by F is equal to Q into V bar cross B bar plus E. Force experienced by conductor carrying current I and length L when placed in a magnetic field B is F is equal to ILB sin theta. The magnetic field dB due to an element of length L dl carrying current I at a point P at a distance smaller from the conductor dB is equal to ideal sin theta by r square. It is called Biot-Savart's law. Equal to Q into V cross B plus E is used to find the total force experienced by a charged particle moving with velocity V in the presence of electric and magnetic fields E and B. F is equal to ILB sin theta is the formula used to find the force experienced by a conductor whose length is L and carrying current I in the magnetic field B. F is equal to ILB sin theta. We are going to see the magnetic field which is formed around the current carrying conductor using the following formulae. The magnetic field dB due to an element of length dl carrying current I at a point P from the r distance is dB is equal to ideal sin theta by r square. By the way, magnetic field intensity at a point due to a straight conductor carrying current I, B is equal to mu 0 by 4 pi into IA by A into sin theta 1 plus sin theta 2. This is the case for a small conductor. When the length of the conductor is considered to be infinite, magnetic field intensity at a distance due to an infinitely long conductor is given by mu 0 by 4 pi into 2I by A, where theta 1 and theta 2 are 90 degrees. Therefore, sin 90 plus sin 90 1 plus 1 2, it will turn out to be mu 0 by 4 pi into 2I by A. Now we are going to see the different problems basing on this formula. Current of 50 amperes in north to south direction is the direction and magnitude of B at a point 2.5 centimeters east of the wire. Using on the formula B is equal to mu 0 by 4 pi into 2I by R, we get equal to 4 into 10 power minus 6 Tesla. Current is flowing from north to south direction. According to Maxwell's right hand rule, the direction of magnetic field is perpendicular to the plane of paper. By the way, what is the magnitude of magnetic force per unit length of a wire carrying current of 8 amperes and making an angle of 30 degrees with the direction of magnetic field of 0.15 Tesla? To find out the force acquired by the conductor carrying current in a uniform magnetic field of 0.15 Tesla, we have to use the formula F is equal to ILB sin theta. Shooting these values, I 8 amperes and length 1 meter and the magnetic field intensity 0.15 Tesla and sin 30, and simplifying it we will get F is equal to 0.6 Newton per meter perpendicularly. Long straight wire carries a current of 35 amperes. What is the magnitude of the field B at the point 20 centimeters away from the wire? As we have already discussed, the formula to be used here is B is equal to mu 0 into 2 pi Ni by 4 pi r. On substituting these values here, 4 pi into 10 power minus 7 into 2 pi into 100 times 100 into 0.4 by 4 pi into 0.08. Therefore, B is equal to 3.14 into 10 power minus 4 Tesla. A long straight wire carries a current of 35 amperes. What is the magnitude of the field B at the point 20 centimeters away from the wire? Magnitude of the field of a long straight wire B is equal to mu 0 I by 2 pi r. Shooting these values I 35 amperes and R 20 into 10 power minus 2 meters in the given formula, we get B is equal to 3.5 into 10 power minus 5 Tesla. In this way, you can solve the given problems using the required formulae. Absolute error is equal to A1 plus A2 plus A3 plus and so on An by n. Mean absolute error is equal to mod delta A1 plus mod delta A2 plus mod delta An by n. Relative error is equal to mean absolute error by absolute error. Percentage error is equal to mean absolute error by absolute error into 100. Scalar product or orthogonal product of vectors I cap I is equal to j cap j is equal to k cap k is equal to 1, but I cap j is equal to j cap k is equal to k cap I is equal to 0. Scalar product of orthogonal vectors I cross I, j cross j, k cross k is equal to 0, but I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. Vector product in Cartesian coordinates can be taken by taking the determinant of I, j, k, ax, ay, az, bx, by, bz. But we all know that area is equal to length into breadth, volume is equal to length into breadth into height, density is nothing but the mass per unit volume. Therefore, density is equal to mass by volume. Speed is equal to distance by time, velocity is equal to displacement by time, acceleration is equal to change in velocity by time interval, instantaneous speed is equal to limit delta t tends to 0 delta s by delta t. Equations of motion when the body moves with uniform acceleration, v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. Let's go through some more formulae in kinematics. Distance travelled by the body in nth second, Sn is equal to u plus a by 2 into 2n minus 1. Equation of path of projectile, y is equal to x tan theta minus g by 2u square cos square theta into x square. Time of flight, t is equal to 2u sin theta by g. Maximum height, h is equal to u square sin square theta by 2g. Horizontal range, u square sin 2 theta by g. Let's go through some more important formulae in rotatory motion. Angular displacement delta theta is equal to linear displacement by radius. Angular velocity omega is equal to angular displacement by time interval. Angular acceleration alpha is equal to change in angular velocity by time taken. Angular momentum L is equal to mvr is equal to m omega r square, because v is equal to r omega. This is called the relation between angular velocity and linear velocity. V is equal to R omega. Relation between angular acceleration and linear acceleration, A is equal to R alpha. Centripetal acceleration, A is equal to V square by R. Centripetal force, F is equal to M into V square by R. When V is replaced by R omega, we get F is equal to mv square by R or mr omega square. Now let us go through kinematic equations and circular motion. Omega is equal to omega naught plus alpha t. Theta is equal to omega naught t plus 1 by 2 alpha t square. Omega square is equal to omega naught square plus 2 alpha theta. Time period of conical pendulum, t is equal to 2 pi into square root of L cos theta by z. Time period of simple pendulum, t is equal to 2 pi into square root of L by z. Linear momentum, P is equal to m into v. Impulse is equal to force into time or change in momentum. Force is equal to mass into acceleration. Weight of the body is equal to mass into acceleration due to gravity. W is equal to mg. Thrust on the rocket at any instant, F is equal to minus u into dm by dt. Velocity of rocket at any instant, V is equal to V naught plus u log e base m naught by m. Limiting friction, F is equal to mu s into r. Kinetic friction, Fk is equal to mu k into r. Normal reaction of plane, R is equal to mg cos theta. Maximum speed of a car on the level road, Vmax is equal to root mu s into rg. Now maximum speed of a car on a banked road, Vmax is equal to rg into mu s plus tan theta by 1 minus mu s tan theta whole power of. When mu s is equal to 0, V is equal to rg tan theta whole power of. Work done is equal to force into displacement. When force is applied with certain angle, work done is equal to Fs cos theta. Power is nothing but rate of doing work, that is equal to work done by time taken. Kinetic energy can be written as half mv square or p square by 2m. Gravitational potential energy is equal to mgh. Elastic potential energy is equal to 1 by 2 kx square. Work energy theorem, W is equal to half mv square minus half mu square. Center of mass of n particles, m1 x1 plus m2 x2 plus and so on, mn x1 by m1 plus m2 plus and so on plus mn. Moment of force is equal to force into perpendicular distance. Moment of inertia, I is equal to mk square. Radius of gyration, k is equal to under root r1 square plus r2 square plus and so on plus rn square by n. Torque is equal to moment of inertia into angular acceleration. Time period of satellites, t is equal to 2 pi into square root of r cube by gm. Orbital velocity v naught is equal to root gm by r. Escape velocity v is equal to root 2 gm by r, that is equal to root 2 gr. Stress is equal to restoring force by area. Strain is equal to change in configuration by original configuration. Hooke's law states that stress is directly proportional to strain. Stress is equal to modulus of velocity into strain. Young's modulus of velocity is y is equal to normal stress by longitudinal strain. Bulk modulus of velocity, k is equal to normal stress by volume strain. Modulus of rigidity, eta is equal to tangential stress by steering strain. Compressibility is equal to reciprocal of modulus, bulk modulus. Safety factor is equal to breaking stress by working stress. Elastic potential energy in a stretched wire, 1 by 2 into stress into strain into volume of the wire. Elastic potential energy per unit volume, 1 by 2 into stress into strain. Elastic potential energy of a stretched spring, 1 by 2 kx square. Thermal stress is equal to force per area, y alpha delta theta. Intraatomic force constant, k is equal to yr naught. Poisson's ratio, sigma is equal to lateral strain by longitudinal strain. Depression of a cantilever, delta is equal to omega L cube by 3y Ig.